Okay, so we're going to be working on factoring today. We're going to factor special cases, and the one that we're going to focus on is going to be the difference between two squares. So let's get to it. We'll see what it looks like. So this is our first example. We have x squared minus 9. Now, we said before it's going to be the difference between squares. And if you remember, the difference means that we have a subtraction problem. So that's our difference. If you look over here, you can see here's our difference. And the difference is located between two squares. This is a perfect square, and this is a perfect square. So we technically have the difference between two squares. And how we factor that is we're going to end up with two binomials. We take the square root of the first perfect square and put that in each of our parentheses. We take the square root of our last perfect square and we put that in each of our parentheses. And because this is the difference between squares, we just put different signs. And just like that, you've factored the difference between squares. And we can always check it by foiling it out. So if we FOIL it out, we'll do our first term is going to give us x squared. Our outer term will give us negative 3x. Our inner term will give us positive 3x. And our last term will give us negative 9. And you can see what's going to happen here. We have our OI, our outer and our inner, is going to just drop out, right? Because negative 3x plus 3x is 0. So we're going to end up with x squared minus 9, which is the thing that we factored to start with. All right, let's do another example. You can see these are not that hard once you know what the, I don't want to say trick is, once you know what the methodology is. So here's an example that doesn't look like it's going to be the difference between squares. But if you remember, every time you factor, you always want to see if there's a GCF. That's always your first attempt. And in this case, there is. So we're going to factor out a 3. Now we're left with x squared minus 4. Having x squared minus 4, we do now have the difference between squares. So the 3 is going to stay there. The x squared minus 4, again, taking the square root of x squared, taking the square root of 4, and we have different signs. And now we've factored it completely. That's as much as we can do. And it doesn't matter whether you have the x plus 2 first or the x minus 2 first, because they're multiplication. Multiplication is commutative. It doesn't really matter which one's first. All right, let's look at another example. This one's a little bit more involved looking. Not that it's harder, just a little bit more. So the first thing that we notice is we have a GCF. So let's factor out the 2. So we take out a 2. Now we have x to the 4th minus 256. Well, this is the difference between squares. So we're going to take the square root of x to the 4th, which is x squared. The square root of 256, which most of you would know at this point in your life, is going to be 16. And we have different signs. So we have a positive and we have a negative. But we're not finished, because this piece over here, this guy, is the difference between squares again. So we have to factor that. So now we have a 2. We have the x squared plus 16. And now this, x squared minus 16, is the difference between squares. So we're going to have an x and an x, because that's the square root of x squared. We're going to have a 4 and 4, because that's the square root of 16. And we're going to have a plus and a minus. Now, again, take careful note. If you look at this one, all right, this looks like you can do something, but you can't, because it's not the difference. That's the sum of squares. And there isn't one of these little factoring things that we do with the sum of squares. So that's what that looks like. And then the last one that we're going to do, this is really kind of simple, but I just want you to see it. Okay, this again is the difference between squares. So even though there's no numerical value anywhere in the problem, we can still factor this. So we get an x and an x here. The square root of y is y and y, plus and minus, just like that. Thanks for watching.